So on number 1, I want to know the probability that the number rolled on a die is a factor of 6. What do I mean by factor of 6?
Good morning.
What do I mean by factor of 6?
Just get the ball rolling here because nobody wants to answer. Is it like numbers that go into 6?
That's exactly what it is. It's numbers that go into 6. So if we're thinking about all the numbers there are on a 6-sided die, one side has 1 dot, one side has 2 dots. We've got 3, 4, 5, and 6. Which ones of those do not go into 6 evenly?
5.
5 does not go into 6 evenly, and 4 does not go into 6 evenly. 1 and 2 and 3, if I divide 6 by a 1, a 2, or a 3, I'm going to get a whole number answer back. If I divide 6 by 6, I'm going to get a whole number answer back. So we've got 4 possible options that are factors of 6 out of all 6 total options. So 4 out of 6. Or if I were to write that as a percentage, that would be approximately 67%. All right, number 2. Instead of looking at just 1 die, I'm looking at 2 die. If I'm rolling 2 die, how many possibilities are there?
Well, one has 6, the other has 6. 6 times 6, 36.
That's exactly right. 6 times 6 gives me 36 total outcomes. I need to know that because that's going to tell me my denominator. So I know my denominator is 36. We want to know the probability that the sum is 4. What operation are we talking about if we say sum? Addition. So I want to add up 2 things and get an answer of 4. If we're thinking about our dice, what's a possible thing that I could roll between the 2 dice so that it adds up to 4?
1, 3, 2, 2,
Yeah.
3, 1.
It could be a 1 and a 3. First I roll the 1 and then I roll the 3. Or maybe I get the same 4, but on the first die I roll a 3 and then I roll a 4. Is that a possibility? I roll a 1 and then a 3, or a 3 and then a 1. Either way, it adds up to 4. And my other option is what?
2, 2.
2 and 2. Is there any other possible way that I could throw the dice and get a sum of 4?
Yeah, if you don't throw 1 and throw the other and get 4.
Well, I have to throw both of them. So if I roll a 4, 5, or 6 on the first dice, I can't get a sum of 4. Yes, ma'am. Mm-hmm. So, because we're looking at, there's only one side that has a 2 on each die, the only way this could happen is if the first die shows me a 2, and then the second die also shows me a 2. Does that make sense? So this one, there's only one way that can happen. Because if I roll a 2 on the first die, the only way I can get here is if this one is also a 2.
Just like an intersection on a graph.
Yes, it's going to look a lot like an intersection. There's only one way to do it there. Here, if I roll a 1 on the first die, I still have a chance to roll a 4 on the second die, but only if I roll a 3. Or if my first die shows a 3, I still have a chance to get a 4, but only if the second die shows a 1. So how many different ways can we get a sum of 4 on the 2 die? 3 different ways. So 3 out of a total of 36.
An 8% chance.
That is an 8% chance. It's about an 8.3% chance. All right, number 3, this is our last probability question. The blood types of 200 people is distributed as follows. Type A blood, there were 50 people. Type B blood, there were 65. Type O was 70. Type AB was 15. If a person from this group is selected at random, what's the probability that this person has O blood type?
Well, if the group is total, then that means the denominator is 200.
Denominator is 200, because there's our total number. What would our numerator be?
70.
70. We have 70 people that have blood type O.
A 35% chance.
That is 35%, right on. The directions had said draw a Venn diagram to help you. If we had drawn a Venn diagram for this.
Okay, I found this one for draw a Venn diagram to help you.
Thank you, Siri. 2 of the circles would be overlapping. O-type blood is kind of off all by itself. It does not overlap with A and B blood type. So our 70 people would be hanging out over here. We would have A and B. Type AB would be in the middle. Right here would be 15 people. Which means just B would be 50. And just A would be 35. All right. Let's go down and look at number 4, solving the system of equations. What would I need to do to solve this system?
Replace one of the x's or y's with something. Don't really know how to put it into my head.
We could choose to use substitution. We could also use the linear combination or the elimination method. That's the one where you multiply and you try to make something cancel out. Could I use that technique here?
Yeah.
Yes, if I multiply the top equation, everybody by 3, that means even the part after the equal sign. Then up on the top, I would have negative 3x. I would have a positive 6y equals positive 30. I'm not going to change anything at all about the bottom. 3x minus 6y equals 12. When I combine those two together, what happens? All of the left side cancels out, so I end up with 0 plus 0. Does the right side cancel out?
Equals to 42.
It equals 42. Is 0 actually equal to 42? So what does that mean here? There is no solutions. There are no solutions there. All right. I want to spend the rest of the class period today taking whatever questions you guys have off of either one of the reviews, the paper review or the Canvas review. There are 2 separate reviews, again, for those of you that weren't here yesterday. 2 separate different reviews. You only have to complete one of them. If you decide to complete both of them, I will give you extra credit. But I will take questions off of either one of those.
How many useless papers I get?
Where would you guys like to start? Well, if nobody has anywhere in particular, let's start with number 1, and I'll take requests after we go through number 1 to maybe get us started. To open a safe, 5 numbers must be entered on a keypad. The keypad contains the numbers 0 through 9, which means as you're setting up the code that will unlock this thing, how many options do you have if you've got from 0 to 9? 10 options here.
Possibly more of those little.
Oh, if you have the extra characters?
Yeah.
It doesn't say anything about extra characters, so I'm assuming it only has 0 through 9 as options for the code.
What about the enter button?
Would this be considered a permutation, where the order that you enter in the numbers into the keypad matters, or a combination, where the order that you enter in the numbers does not matter?
Combination before the thing is set, permutation after.
This is a permutation.
But like if you don't care about the lot number, then you can just enter the numbers randomly and then it becomes a permutation after.
Technically, it's still a permutation even when you're thinking about setting it up, because even though you might not care about it, it does matter. Does that make sense?
So you're saying all combination locks are permutation locks?
They really are. All combination locks are actually permutation locks, yes. Permutation, because the order that you enter the numbers in matters.
So you'd say that we could basically sue for false advertisement or false branding?
No, it's the difference between common everyday language and specific mathematical vocabulary.
This car dealership got sued because they didn't give somebody a car for giving them a million bananas.
I heard that, yeah. Won't open if you put the numbers in the wrong order. Okay, so this is an example of a permutation. I want to know how many possible ways you can enter these 5 numbers into the safe. If you were making up a code for this safe, and you're like, I'm really worried I'm going to forget it, so I'm just going to make this code 12121. Could you do that? So repeating numbers is allowed when you're setting this code, right? How many options would you have to choose from for the first number in the code?
10.
10 options.
And 10 again.
And 10 again.
And 10 again.
And 10 for the third number. 10 for the fourth number. And finally,
10.
10 for the fifth number. I don't know how my pen got smaller here. There we go. So we have 10 possible options each time we go to press a button. What do I want to do with each of those numbers if I want to figure out the total number of possibilities? What do I do with these numbers now? Multiply them. So we're going to multiply 10 by itself 5 times, or 10 to the 5th power. If you put 10 to the 5th power in your calculator, what do you get? 100,000. It's a 1 with 5 zeros behind it. And here's a useful hint. Whenever we are multiplying 10 by itself over and over, however many times you multiply by 10, that's how many zeros you're going to have. So since we multiplied by 10 5 times, we have 5 zeros here. For part C, it says if no numbers are repeated. So now when I go to type in the numbers on the keypad, how many choices do I have for the first one?
10.
10 for the first number.
And then down 1 until you reach the 5th.
And then down 1, because I can't repeat the number, so now I only have 9 to choose from. And then I have 8, and then 7, and then 6. This is exactly the same thing as saying I have 10 options, order matters, so it's a permutation, and I'm going to choose 5 of them. No matter which way you put it into your calculator, what do you get back? 10 times 9 times 8 times 7 times 6, or 10 permutation 5?
30,240.
30,240. Which is to say that if the only thing you know about somebody's code for this safe is that the numbers don't repeat, you're going to be trying for a while if you try to break their code. Part D here, what is the probability? When we see probability, I know I need to write what kind of number? Fraction. What is the probability that the safe's 5 numbers do not repeat? So the thing I'm interested in happening goes up in my numerator. Non-repeat codes go up here. All possible codes go down here.
So 100,000 would go into the denominator, 30,000. Yeah, 30,240 would go into the numerator.
That's exactly correct. 30,240 goes in my numerator. 100,000 would go in the denominator. How did it say it wanted my answer? As a percent. So I'm going to need to grab my calculator. I'm going to need to divide this. What do you get when you divide this on your calculator?
.3024.
0.3024. So now how do I write it as a percent? Yes, we're going to move the decimal point 2 spaces, or the equivalent of multiplying by 100, and that will give us 30.24%. All right, one more part to this question. We've hit a lot of big ideas from this unit in this question. Select all the choices below that are correct mathematical representations of part C above. Which ones of those jump out at you as correct mathematical representations? How did we find the answer to part C?
Top.
Yep. We've got this one right here. 10 times 9 times 8 times 7 times 6. Any of the others? 10p5. Sorry, I couldn't quite hear the end of what you had said earlier. I thought that's what I'd heard. 10p5. There is one more up here that is correct. You have to do a little bit of manipulation with it to see that it's correct. But there's one other up here that would result in the exact same answer. Yes, this one right here is exactly the same. 10 with the exclamation point is 10 factorial, so that'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom in the denominator, we have 5 factorial, so that would be 5 times 4 times 3 times 2 times 1. Anything that is the same between the numerator and the denominator would cancel out. So my 1s would cancel, my 2s would cancel, 3s, 4s, and the 5s. And so we end up with something that's exactly the same as what we have right next to it. Did anybody have any questions that they've thought of while we were going through number 1?
Yeah, you know what? Let's just do random number 7.
Number 7 sounds good. We want to know whether the events having 2 doors and the car being red are independent events. The way we test for independence is we take the probability of the intersection, so 2-door and red, and we compare that to the probabilities of each of the events on their own, and we multiply those probabilities together. So the product of the individual probabilities. So the first thing I'm going to need to find is the intersection over here. Running out of room to write my words. Intersection. So I'm looking at this table. Here's 2 doors. Here's red cars. Where does that row and that column intersect?
Right at the top of the button.
Yep. Right at the top here. There are 180 red 2-door cars. So 180 would be my numerator. Out of how many cars total? 1,000. And I want to know whether or not that is equal to the probability of a 2-door car. What's the probability that any car on this lot has just 2 doors? 600 out of 1,000. We're going to multiply that by the probability that any car on this lot is a red car. 300 out of 1,000, yes. If these are equal, then they are independent. And if they are not equal, then they are not independent. So I'm going to take this side and put it into my calculator. If you do 180 divided by 1,000, what do you get on your calculator? 0.18. I need to grab my calculator for these other 2. 600 divided by 1,000 is what? .6. We're going to multiply that after we change this next one into its decimal form. 300 divided by 1,000? 0.3. So now I want you to multiply 0.6 and 0.3. 0.18. Are the 2 sides of my equation actually equal? Do I have the same thing on both sides?
Yes.
Yes. So what does that mean about this? They are independent, yes. So yes, they are independent. There's no relationship between these 2. when you multiply the probabilities of the individual events together, and that is the same thing as the intersection, the and. They are independent and there's no relationship there. If you multiply them and it's not equal, then they are not independent. One of them is influencing the other somehow. What else would you guys like to look at? Number 5? Absolutely. A bike lock combination contains 3 numbers ranging from 0 to 49. If it goes from 0 to 49, how many options do we have there? 50 options. We've been given a couple hints about this particular bike lock combination. The first number in the combination is a 5, a 6, or a 7. We're not sure which one, but it's one of those 3. So that is 3 options right there. And then it says that the second number is not a 5, a 6, or a 7. How many options would we have to choose from for the second number if what we know about it is that it's not a 5, a 6, or a 7?
47.
47. We had 50 total options. Minus 3 options. For a total of 47 options for the second number. So using these hints, how many combinations, although we actually know they're permutations because the order matters, how many are possible given this information? So how many choices do we have for the first number?
3.
3 choices, because it has to be a 5, a 6, or a 7. How many choices do we have for the second number?
47.
47. How many choices do we have for the third number?
All of them.
All of them, which is how many?
50.
50. They didn't give us any hints about that one, so it could be any of those. What do I do with these 3 numbers if I want to find out the total possible number of codes that would meet these criteria?
Times them.
Multiply them. With probabilities, when in doubt, we multiply things. If we multiply these 3 together, yep, 7,050 different codes.
Imagine making a same combination lock on one of your tires on a vehicle. Little note saying, riddle me this.
That would not be fun. I would probably be late for work. What is the probability? Probability means I'm going to write what?
Fraction.
I'm going to write a fraction. What is the probability that this right here is the correct code?
It's a one-shot code.
Yep. This is one option right here. So one option out of how many total?
7,050.
7,050. Do you have a very good chance of guessing it on the first try?
No.
No. Absolutely not. I don't have my calculator near me, but go ahead and divide that. I'm curious what that is as a percent. It's pretty low.
0.000141844.
0.00014. So if I change this into a percentage, that's 0.014%.
Hey, that means every time that you guess, it goes up 0.014%.
Oh. So not a very good chance if you're just going to try to guess. What else would you guys like to look at? Which one? Number 4? Absolutely. Oh, I had number 4 up. Okay. Dave, Mary, Lisa, Jason, and Charles are running the 300-meter hurdles in the state track and field meet. Assuming that all 5 runners have an equal opportunity of winning the race, what's the probability that Jason wins? Jason is how many of the runners?
1.
1 out of
5.
5. So Jason has about a 20% chance of coming out as the winner. How many different outcomes are possible?
Does that include all the places and stuff?
That does include all the places, yes.
120.
120. Tell me how you came up with that. We could do it as 5 factorial. How else could I represent this and get the same answer because it has the same meaning? 5 times 4 times 3 times 2 times 1. Or that's the same as what? When we're talking about running a race, does order matter when you cross the finish line? So would it be a combination or a permutation? Permutation. 5 people are running the race. It is a permutation. Barring any unforeseen injuries, all 5 people will cross the finish line, so they will place somewhere. It's exactly the same thing as 5 factorial. And there are 120 different outcomes. Thank you, ma'am. All right. You guys okay if we go look at that tree diagram thing? Let's go look at that guy. That is number 20, so it's towards the back. This thing right here. I want to remind us how to go about filling this in. It says at Math Academy, the probability that a student is currently taking Spanish is 0.65 or 65%. Where would that go on my tree diagram? Taking Spanish now, so 0.65, 65%. So what should I put down here with not taking Spanish right now?
0.35.
0.35, 35%. We subtracted it from 100% because you're either taking it now or you're not taking it now. So 100% minus 65% is how we came up with this right here. Anytime the branches split, they have to add up to 100% because you got to pick one way or the other. All right. I see right down here that this one is 0.95, 95%. That's the probability that if somebody is not taking Spanish now, then they didn't take it in 8th grade. What's the chance that they're not taking Spanish anymore, but they did when they were in 8th grade? 0.05 or 5%. Because again, it has to add up to 100%. The way we find these numbers at the end, this is the probability of both things happening, the and, the intersection. We multiply along these branches here. So to get this value at the end, they multiplied 0.35 with this 0.05. Verify that on your calculator. .35 times 0.05, you should get 0.0175. Okay, so since we know that that's how you get the numbers at the end, what would I have right here? Down at the very bottom of this branch. How would I get that number? Yes, we're going to multiply the 0.35 with the 0.95. And that's how we will get this. So what do we get there? 0.3325. All right, let's see if we can work backwards a little bit. I know this is 0.65. I don't know what this is, but I know when you multiply the two together, you get this. So 0.65 times I don't know what is what gave me the 0.1625.
We can find out by looking at the later half of the question.
Yes, we can. What did you see in the later half of the question?
If a student is taking Spanish, then the probability that he or she took Spanish in 8th grade is 0.75.
So taking Spanish now, took Spanish in 8th grade, 0.75, so 75%. So if they're taking Spanish right now, what's the chance that they didn't take it in 8th grade?
25%.
25%. Verify that on your calculators. If I do 0.65 times 0.25, do we get 0.1625? Okay, so we have one more thing to figure out here, and that is this one right here. How do I find that number? Yes, 0.65 times 0.75. And what does that give us?
0.4875.
0.4875. We're going to look at part B and then shut it down, but part B's answer is already sitting up here on the screen. It says, find the probability that a randomly selected student at Math Academy is currently taking Spanish and took Spanish in 8th grade. Well, here's the path for taking Spanish now. Here's the path for took Spanish in 8th grade. So this is the probability of now and 8th grade. So 0.4875. But they said they wanted me to write my answer as a percent.
Times 100.
Yes, 48.75%. Beautiful. I will be posting the video from this class period and from second period because I'm assuming people will ask about different problem numbers. Also, if you look on Canvas today, down at the very, 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 very bottom of today's lesson, which you get to from modules, I've got all the answers, but then down at the very bottom, I have my work. If you click on this link down here for the PDF, it has all of my worked out solutions for this paper copy of the review. You need to complete either the Canvas version or the paper version by tomorrow. If you do them both, I will give you extra credit. Okay?
And how much extra credit?